processing n jobs through m machines. Okay, 4 jobs 1, 2, 3 and 4 are to be processed on each of the 5 machines A, B, C, D and E in the order A, B, C, D, E. Okay, so this is the order of processing. Find the total minimum elapsed time if no passing of jobs is permitted. Also determine idle time for each machine. Okay, so here we have 4 different jobs and 5 different machines, and this is the duration, processing time. With this information, they are asking us to calculate minimum elapsed time, also determine idle time for each machine. Now let's see the solution. In order to solve the problem, the first step is we need to find minimum duration on first machine and last machine. Okay, see, for the first machine, the minimum duration is 10. Okay, so write 10 here. In the same way, find out the minimum duration for the last machine. Here the last machine is E. Okay, so the minimum duration is 12. Okay, see, after finding the minimum duration of first machine and last machine, now we need to find out the maximum duration on the machines in between first and last. Okay, here we have B, C, D. Now we need to find out the maximum duration on each and every machine. For B, maximum duration is 12. For the next one, maximum duration 10. And then for D, maximum duration is 12. Okay, now the next step is we need to find maximum of maximum duration between A and E. That is, in between A and E, we have B, C, D, no. So in that, we need to find out the maximum duration. So which is the maximum duration among these 3 machines? 12. So write 12. This is the maximum of maximum. Okay, so we found minimum duration on first machine and last machine, and maximum of maximum in between A and E, that is B, C, D. Okay, after finding this, we need to check the condition. Here we have 2 conditions. Now let's see the conditions. See the condition. The first condition is minimum duration of first machine should be greater than or equal to maximum of maximum duration of B, C, D. Okay, so here we have minimum duration 10. Maximum of maximum duration is 12. Okay, just see the condition. 10 should be greater than or equal to 12. No, the first condition is not satisfied because 10 is less than 12. Now, let's see the second condition. The second condition is minimum duration of last machine, that is E. How much? 12. Duration is 12. No, the 12 should be greater than or equal to maximum of maximum duration of B, C, D. Maximum is 12. No. So 12 greater than or equal to 12. So both are equal, no. So this particular condition is satisfied. Now you can proceed further. If both the conditions are not satisfied means we cannot solve this problem according to this method. So there is another method to solve the problem if both the conditions are failed. Okay, that we will see in the next video. Now let's see the second step. The next step is we need to find the optimum sequence. For that, convert the original problem into 2 machines. Here we have 5 machines. No, we need to convert into 2 machines. That is, we need to introduce 2 fictitious, that is imaginary machine. Machine A and machine B. Okay, for machine A duration, just add up all the duration except the last machine. That is A, B, C, D. Okay, for machine B duration, just add up all the machine duration except the first one. That is B, C, D, E. Okay, so this is the duration for fictitious machines, machine A and machine B. Now we can proceed the simple steps to find out the optimum sequence. For that, just find out the minimum duration among machine A and machine B. Okay, see which is the minimum value or minimum duration? 28. If minimum duration occurs in machine B, then we have to allocate this particular job in the backward direction first. Okay, here 28 falling machine B, no. So we need to allocate this particular job in the backward direction first. So assign 4 here. Okay, then next minimum duration is 34. But this duration occurs in machine A. So we need to allocate this job in the forward direction first. 1. The next minimum duration is 40. This is occurs in mission A. So we need to assign this job in the forward direction. Okay. Job 3. The last one is job 2. So this is the optimum sequence. With this optimum sequence, we are going to proceed further. The next step is we need to compute the minimum elapsed time. Okay, for that, construct the table like this with 5 different machines. In the original problem, we have 5 machines, no? A, B, C, D, and E, and jobs. 4 jobs are there, but we have to arrange the jobs according to the optimum sequence. What is the optimum sequence? 1, 3, 2, and 4. Okay, and we need to enter duration for all the 5 machines. I have entered the duration for all the 5 machines according to the optimum sequence. Okay, now we need to calculate in time and out time for all the 5 machines for all the 4 jobs in order to find out the total minimum elapsed time. Now let's see the calculation of in time and out time for first mission, that is mission A. Mission A is going to process 4 different jobs according to this order. Okay, the first one is job 1. So for the first job, in time is 0. In time 0 plus duration 14. Out time is 0 plus 14, 14. So after completion of the first job, mission A will take up the next job. So for the next job, in time is out time of the previous job, 14. 14 plus duration 10, 24 is the out time. And this will be the in time for the next job. 24 plus duration 12. So out time is 36. And this will be the in time for next job. 36 plus 16, 52. So this is the out time for the last job. After finding the in time and out time for mission A, in the same way we need to calculate for all other missions. Now let's see second mission, mission B. For the first job, after completion of the first job through mission A, this job will move on to mission B at 14th minute. Okay, this is the in time. That is out time of the previous mission. Okay, 14 is the in time. Now 14 plus 10 duration is equal to 24. This is the out time. So after finding the out time for the first job, the next job in time is we need to compare the previous mission's out time and previous job's out time. Whichever is higher will be the in time for the next job. Okay, here 24, 24 same one, you know. So you can put 24 as in time. 24 plus 8, 32 is the out time. See the next job. Okay, we need to compare the previous mission's out time and previous job out time. Whichever is higher will be the in time. Okay, 32 and 36. So 36 is the highest duration now. So that is the in time for next job. So 36 plus 12, 48 is the out time. Okay, for the next job, 48 and 52. 52 is the highest duration. So 52 is the in time plus 6, 58. In the same way, for the next mission. Okay, for the first job, after completion of the process through B, it will move on to mission C. So in time is 24. So 24 plus 4, 28. Now for the next job, just compare the duration. Whichever is higher, 32 is the highest duration. So 32 is the in time plus 10 duration, 42. For the next one, 42 and 48, which is the highest, 48. So 48 plus 8, 56. For the next one, just compare 56 and 58. 58 is the highest duration. So 58 plus 6, 64. In the same way, for the next mission, 28 is the end time for next mission. 28 plus 6, 34. Then for the next job, just compare. 42 is the highest duration. No. So 42 is the end time for the next job. 42 plus 12, 54. For the next job, just compare. 56 is the highest duration. 56 plus 10, 66. Okay, the next one here, 64 is the completion time, but here 66, which is the highest duration. 66. This will be the in time for next job. So 66 plus 4, 70. Okay, the same way for the next one, 34 is the completion. No, the next in time is 34. So 34 plus 18, 52. Next, compare. 54 is the highest duration. 54 plus 16, 70. The next duration is just compare 70. 70 is the in time plus 20, 90. The next one, 70 and 90. 90 is the highest duration. So 90 plus 12, 102. Okay, so this is the way to find out in time and out time on 5 different machines. And 102 is the minimum elapsed time. That is 102 time unit is the minimum elapsed time. Now let's see how to calculate idle time on 5 different machines. Now we need to find out the idle time on machines. Here we have 5 machines now, A, B, C, D, and we need to find out the idle time for each and every machine individually. For that, just compare the out time and in time, okay, in order to find out any idle time. For the first machine, 14 out time, next in time 14, no difference. 24, 24, no difference. 36, 36, no difference. So out time for the first machine is 52. Now this machine has to wait till the last elapsed time, that is 102, no. From 52 to 102 is the idle time for machine A. Okay, so 102 is the total elapsed time minus, so first machine A completion time is 52. The difference is equal to 50 time unit. So this is the idle time for machine A. In the same way for machine B. See, machine B starts its work only in the 14th minute. Okay, so after processing through machine A, this job will start, okay, on machine B at 14th minute. So till such time, machine B is idle. That is the idle time for machine B. Plus, just see the out time and in time. 24, 24, no difference. 32, 36. Here we have 4 minutes. Next, 48, 52. Here also we have difference. 4 minutes plus 4. Okay, machine B will complete process at 58th minute. From this minute to the last total elapsed time, that is 102. The difference between 102 and 58 is the idle time for machine B. Okay, so plus 102 minus 58. So total 66 time unit. In the same way for machine C. So machine C starts at 24th minute. Okay, that is the idle time. Plus, just compare the out time and in time. Yes, here we have difference. Duration is 4 minutes difference. 4 plus 42 and 48. What is the difference? 6 minutes is idle time. Then 56 and 58. So here 2 minutes. 2. In the same way, compare machine C's last out time with the total elapsed time. Okay, that is 102 minus 64. Okay, the total idle time on machine C is 74 time unit. In the same way, for the next machine D. Machine D starts its work at 28th minute. Okay, till such time it's an idle time for machine D. 28 plus, just compare the out time and end time. 34 and 42, 8 minutes. 8 plus, next 54, 56. Here 2 minutes. Plus 66, 66, no difference. Okay, so the last one is 70 is the out time of machine D for the last job. Okay, then we need to compare this duration with total elapsed time 102. The difference is the idle time for machine D. 102 minus 70. So total 70 time unit. Okay, the next one. In the same way for machine E. So machine E starting time is 34 minutes. No, till such time it's an idle time for machine E. So 34 plus 52 and 54, 2 minutes. 70, 70, no difference. 90, 90, no difference. This is the last duration. Okay, you cannot compare with the total elapsed time for the last machine. That's all. So total idle time for machine E is 34 plus 2. So total 36 time unit. So this is the way to find out the idle time on machines individually. Look at the problem. So far we have seen the calculation of total minimum elapsed time and idle time for each machine. Okay. In the next video we are going to see second case, that is If both the conditions are not satisfied, then how to solve the problem?